Hey, good morning, everyone, and welcome to the 2020 edition of the Royal Tyrrell Museum Speaker Series. Today, the Royal Tyrrell Museum and its cooperating society are proud to present Dr. Jerry Osborn. Jerry is a professor emeritus in the Department of Geoscience at the University of Calgary. Jerry is originally from California. He obtained his bachelor's and PhD from the University of California, Berkeley. For his PhD, Jerry studied the Quaternary glacial geology and geomorphology of the Uinta Mountains and Uinta Basin in the state of Utah. After completing his PhD, he moved to Calgary to accept a position in the Department of Geology and Geophysics, the name of the department at the time, at the University of Calgary, where he spent his career until his retirement a few years ago. Jerry's research interests include the glacial and climate history of the Canadian Cordillera, the glacial history of the Great Basin of the United States, the superficial geology and natural hazards of the Calgary area, and figuring out what makes mountains pointy and plains flat. He is also interested in the relations between science and society, particularly as illustrated by climate change issues, which will be the topic of his talk today. So without further delay, I present you Dr. Jerry Osborn.
Thank you, Francois. And I must say that the pronunciation of Uinta was impeccable. It often doesn't go that well, actually. So today we're going to talk about climate change, specifically warming, which is of great interest these days around the world, both for scientific and for sociological reasons. On the one hand, it may be the first issue in human history where the whole world, more or less collectively, has to make a decision about something. And doing nothing is a possible decision. And on the other hand, climate change is part of a huge culture war being waged in North America between what we could loosely call conservatives and what we could loosely call liberals. So it's a very interesting issue. We're gonna touch on both of those aspects here, rather briefly, of course. So the way I want to handle this is, we'll start off with a kind of a Dave Letterman kind of shtick. Top 5 reasons why there's a lot of confusion, why it's hard to make sense out of global warming issues. Then we'll look at the politics and the culture war. Then we'll get into the science. And we'll end with some projections of what might happen in this century and where we're at relative to those projections. Okay, that's the plan. So I think almost everybody agrees. There might still be a few oil company types in downtown Calgary who don't believe it's getting warmer, but almost everybody believes it's getting warmer now, despite the fact that we still get some good cold spells in Alberta winters. My 2 favorite images from 2019, this is the first one, sled dogs walking through water on the Greenland ice sheet, and this is the second one, manure self-igniting in the heat wave in Europe last summer and sparking this big wildfire. So if I may be blunt, what we're talking about here is spontaneous combustion of shit. That is a very scary thought. Okay. But let's get to the top 5 reasons why it's hard to make sense of the global warming issue. Okay, number 1, the process of science is not well understood. There are scientists on both sides of this debate. Now, admittedly, a huge majority on one side, we'll call that the mainstream side, and a very tiny minority on the other side. But there are a handful of genuine climate scientists, published peer-reviewed papers, who don't buy into anthropogenic warming very much. How could this be? How could you have scientists on both sides of an issue? Well, I'm here to tell you this is normal science. Every scientific conclusion has scientists on both sides of the issue. You probably didn't know that. Plate tectonics, you probably think, is a thing. It's in every geology textbook. There's about 3 professional geologists in the world today who do not think plate tectonics is a thing. They're professional geologists with PhDs. They make a living in geology. They don't buy into plate tectonics. I could give you many such examples. HIV/AIDS, expansion of the universe. There's always a small minority with a different opinion. This is okay. This is normal science. Some scientists act both as advocates and scientists at the same time. This gets a little tricky because you don't know whether they're giving you science or whether they're giving you advocacy or whether or not it's the same thing. And advocates may cherry pick the evidence they offer you. This is a huge industry in the skeptical camp, cherry picking of evidence. Different questions are fused together. Is it getting warmer? If it is it necessarily anthropogenic? If it is that necessarily a bad thing? These questions get fused together and you're not sure what's actually being addressed. Okay, here's the number one reason why it's hard to make sense of the global warming issue. The global warming debate is not about global warming. No wonder it's so confusing. Okay, let me illustrate this point with a little anecdote from the University of Calgary campus back in 2011. Rex Murphy, who used to be the correspondent for Cross Country Checkup on CBC, he was making a tour of college campuses across Canada on behalf of the Frontier Institute, which is kind of a free enterprise think tank in Western Canada. And Rex is a pretty conservative guy, very excellent speaker. So I went to his talk at Mac Hall on the U of C campus, expecting to hear the latest arguments against anthropogenic warming. Well, in a 1 hour talk titled Global Warming 101, Rex talked about scientists should not be advocates while doing science. We've alluded to that already. Comparison of anthropogenic warming skeptics to Holocaust deniers is reprehensible, because some blogger had made this comparison a few months earlier. And thirdly, development of the oil sands is good for Canada and particularly good for Newfoundlanders, because after they trash their fisheries, they can come west and work in the oil sands. In a 1 hour talk called Global Warming 101, not one iota of information or opinion about global warming. Why not? Because the global warming debate is not about global warming. So what is it about then? Let's get into some politics. First, we'll look at the partisan divide in the United States. We'll go down to this part of the table, which starts with the most conservative Republicans. So we're talking Tea Party types. Okay. And this color is buy-in to warming being caused by human activity. Okay. Most conservative Republicans, 15% agree with human anthropogenic warming. More moderate or liberal Republicans, 36% of those buy into anthropogenic warming. The most conservative Democrats, 55%, and then the most liberal Democrats, we're talking Bernie Sanders types, 76%. Like we have a linear correlation between political outlook and buy into anthropogenic warming or not. Political outlook is the number one indicator of your opinion on anthropogenic warming, beating out age, gender, education. Political outlook is the indicator of your stance on anthropogenic warming. Let's look at the partisan divide in Canada. This poll is 2014, but ECO says 2017 data was very similar. Okay, this color is buy-in to anthropogenic warming. Okay, the most conservative party on this list is the Conservative Party. That's why it's the most conservative party. 33% buy into anthropogenic warming. Next would be the Liberal Party, 81%. That's a huge step, 33 to 81. And then what's more liberal in the Liberals? Maybe the NDP at 83%. What's the greenest party of all? The Green Party, 91%. Well, the Bloc Québécois kind of has its own agenda. It doesn't fit neatly into this picture. But here again, we see a nice correlation between political ideology and stance on anthropogenic warming. Mildenberger did an interesting study published in 2016 where he looked at the same question. He asked the same question, but he did it by federal writing. So warm colors buy in to anthropogenic warming, and the bolder the warm color, the more the buy-in. And cool colors, no, less than 50%. And the cooler the color, the less the buy-in. So where do we see the most buy-in to anthropogenic warming? Coastal BC, southern Quebec and Ontario, and the Maritimes. The Maritimes is a bit of a surprise to me, but southern Ontario and Quebec, certainly no surprise. This is where we would expect to find the most liberal political outlook and the most buy-in to anthropogenic warming. Where do we see the cool colors? Let's see. Well, it looks like Alberta and Saskatchewan, less than 50% buy-in. Where are we right now? We're right in this riding here, which is what, Battle River, Crowfoot, I think. Looks pretty conservative. Yeah, I think there's some conservative outlooks out there. Okay. If you magnify Edmonton and Calgary, which we do here, you can see there are little islands of warmth surrounded by coolness. This is interesting because this riding right here, which is Calgary Center, that contains downtown Calgary, which is the oil patch, which is famous, has a reputation for climate change skepticism. And yet it's a warm color. Well, my hypothesis is the older oil company entrepreneurs, they work here, but they live there. That's my hypothesis. Okay, but again, the point is we find a nice correlation between outlook on climate change and political ideology. Now, what is it that bothers the conservative faction of society so much about anthropogenic warming? Is it that they don't want to get warm? What is it that why don't they buy in? Okay, I think it's well expressed, for example, in this book, which is one of many which will allegedly show you why global warming is a hoax. And we're going to call this the right-wing agenda attached to climate change. And it says in this book, climate change has little to do with the state of the environment and much to do with shackling capitalism and transforming the American way of life in the interest of global wealth redistribution. So it's actually not the climate change that's being argued. It's the perceived potential political consequences of dealing with climate change. Let's look at Christopher Monckton, who's a Brit, but he travels around North America giving speeches to anybody that'll listen. He talked to the Calgary Chamber of Commerce, about 8 years ago or so, and they listened. So he says, the communists who piled out of the Berlin Wall and into the environmental movement, who took over Greenpeace, et cetera, et cetera, et cetera, they are about to impose a communist world government on the world. That's redundant, but you get the drift. Okay? The same fears as expressed in this previous book, in the previous slide, that socialists are going to take over the world and create a world government. They're going to interfere with our liberty. In fundamental, let's say, conservative religious circles, such as fundamental Christianity or Christian fundamentalism, global warming has now assumed this aura of danger. It's now a kind of a dangerous idea, somewhat equivalent to evolution as a dangerous idea. And on this intelligent design website, evolution and global warming are both considered as bad news. In Wyoming, if you teach climate change, you're going to wreck the state's economy. And still, in Wyoming, you're not allowed to say, in a science class in high school, you're not allowed to say, increasing greenhouse gases makes it warmer. But you are allowed to say that decreasing greenhouse gases makes it cooler. I kid you not. So, climate change is about politics. Let us not presume that it's only the right wing that drapes climate change science with a social agenda. No, the left wing does just as much. And there are plenty of papers out there and books and conferences about climate change and global justice, climate change, human rights. Here's a series of UN websites about linkages between gender and climate change. So the left wing has draped the science with this big social agenda as well. Now there's so much social agenda draped over climate change that, and I have bolded this line out of a published paper here, debates about climate policy and debates about climate science are impossible to disaggregate. Sociologists have had a field day studying climate change denial in light of the science, which is pretty robust by now. And here's one example, study from Duke. People will evaluate scientific evidence based on whether they view its policy implications as politically desirable. If they don't, then they tend to deny the problem even exists. And in my conversations with geologists in downtown Calgary, I see this shining through. I think this is a good summary of the political situation here in a chapter in a book about organized climate change denial. It says, viewed through a broader theoretical lens, climate change denial can be seen as part of a more sweeping effort to defend the modern Western social order, which has been built by an industrial capitalism powered by fossil fuels. Amen. Since anthropogenic climate change is a major unintended consequence of fossil fuel use, acknowledging its reality poses a fundamental critique of the industrial capitalist economic system. That is what the global warming debate is about. Now, does the right wing have good reason to fear, socialists talking about changing capitalism? Maybe. This is not really discussed because the environmentalists are talking up here and the defenders of fossil fuel use are talking down here, and they don't talk to each other. So until they actually talk to each other, we're not going to get anywhere really in solving our problems. Okay, so anyway, the bottom line here, climate change is now part of this huge overall culture war between what we loosely call the left wing and the right wing. And on both sides, on both poles of this debate, there is money being spent to try and convince you to believe in a certain worldview, in a certain way to think. On the left wing, we have the Koch Brothers Fund, which funds environmental organizations, and some of this money has dribbled into Canada to fund anti-oil sands development groups. This is what Vivian Krause is so worked up about. There's even more money on the right-wing side. The Koch brothers being a great example. Now there's only one Koch brother left because one died last year. But the Koch brothers, which are multi-billionaires who made a lot of their money from fossil fuel consumption, have spent billions supporting right-wing think tanks whose mission is to convince you that climate change is not a problem. In fact, it's a hoax. And then there's the oil companies themselves, which have spent all sorts of money also supporting these conservative think tanks. So money's being spent to try and convince you of a point of view. And some of you are in this point of view, and some of you are in that point of view. Depends on, if you're an American, it depends on whether you watch Fox News or MSNBC. Because people tend to look at the media that supports their pre-existing point of view. And now we have personalities in the political mix. We got Greta Thunberg here, who I understand the other day has been nominated for a Nobel Prize, the same one that Al Gore participated in. And we have Vivian Krause, who's upset because this American environmental money is being spent to lock up the oil sands. So lots of interesting political stuff going on over this issue. So that's just some of the stuff going on. Let's now leave that aside and look at the science and keep it totally divorced from any social issue, which is not what's happening out there in the world now. You're getting this. But let's look at the science just by itself. Okay. A couple of background items to give us some context to help us understand the scientific conclusions. One is that climate is always changing naturally. And this is just one example of an attempt to reconstruct former climate. This is a temperature curve from the southern oceans using ice core data, going way back more than 60 million years ago, almost as far back as the critters that Francois likes to study. And we see that mean annual temperature of the ocean anyway goes up and down, gradually declines as we get to the present day here. And this is the ice ages, which is pretty cool. Okay. In a couple of ways. Okay. So a lot of geologists have asked the question, well, if climate is always changing naturally, how do we know that current warming is not part of a natural cycle? Excellent question. And one that should be investigated, and in fact, one that has been much investigated. And we'll look at some of the results here in a minute. But the main thing to consider is just because climate changes naturally does not mean that climate cannot change anthropogenically at the same time. An analogy is fire. Fire starts naturally from lightning strikes. And as we know now, also from spontaneous combustion of shit. Okay, so because fire starts naturally, does that mean fire cannot also start anthropogenically at the same time? No, it doesn't mean that. Well, how do we tell the difference? We might send out the arson squad to look for evidence of anthropogenic cause. We do the same thing in climate science. We send out the equivalent of the arson squad. Second background item, vastly underappreciated by the public. A few degrees of mean annual temperature change is a big deal, unlike a few degrees of weather change, which is not a big deal, particularly in Alberta. But when we're talking mean annual temperature, we're talking climate, not weather. And the best way to illustrate that is by looking at the difference in mean annual temperature between a Canada that looks like this, where we're covered by ice, and there's, right here in this auditorium, there's a kilometer of ice over our heads during a full glaciation, versus today, which is an interglacial period. The difference between then and now, according to the latest and most rigorous study, is 4 degrees Celsius. 4 degrees between today and Canada being covered by ice. So a few degrees, big. So table that motion in your brain for a few minutes. Okay. And thirdly, let's just make sure we understand the greenhouse effect before we talk about the consequences. It's actually pretty simple, the basics of it. We have incoming solar radiation in visible wavelengths. We can see the sun, and that heats up the Earth. The Earth, in response, re-emits radiation back into space. But here's the trick. It does so at a different wavelength. The Earth emits infrared radiation instead of visible. And because infrared has a longer wavelength, it's commonly referred to as long wave radiation. So there's the outgoing long wave radiation heading back out into space. And most of it will get there. But there's these pesky little molecules out there in the air called greenhouse gases. And these greenhouse gases are transparent to visible light, so they let all the solar radiation in. But they're not entirely transparent to long wave radiation. This is the key to the greenhouse effect. So you see this arrow here. Some of the outgoing long wave radiation is absorbed by these greenhouse gas molecules, and the molecules get all excited with this energy for a little while. Then they re-emit that new energy back in all directions to get rid of that extra energy. So one of those directions is back to the Earth's surface. That makes the Earth warmer than it would otherwise be. So I want to emphasize that the greenhouse effect is a good thing. It's natural. We've had CO2 in the atmosphere for billions of years. And that makes the Earth warm, and it's why we like to live on the Earth rather than Mars. So what's happening now is we are not creating a new greenhouse effect. We are enhancing the old greenhouse effect. So on this diagram, everything's the same except this arrow, which is the intercepted long-wave radiation coming back to Earth, is thicker than that arrow. So it's getting warmer on the Earth's surface because we're getting more of this long-wave radiation. So this is an enhanced greenhouse effect, which has always been there. Okay, so that's the greenhouse effect. Let's look at what's happening right now. This is a graph of mean annual temperatures of the Earth, combining all the weather stations on land around the world and all the monitors out at sea. There's a lot of temperature monitors on the surface of the ocean and down to 2,000 meters depth. I don't know how they do this. And each one of these squares is the mean annual temperature of the Earth with all this data for 1 year. Starting in 1880, considered to be about the time the reliable thermometer was invented, and ending in 2019, that square right there. Okay, so what do we see? See a lot of small scale, high frequency ups and downs. These are natural climate change forcings like 11-year sunspot cycle. Internal oscillations like El Nino, La Nina. So getting small scale stuff, so we do a running average through the small scale stuff, and we see some ups and downs through the 20th century, and then starting about 1970, this upward trend. And this upward trend is what's of interest to climatologists presently, because this cannot be explained by natural forcings. This largely can, as we'll see. Okay. This graph is assembled by the Goddard Institute, which is part of NASA. These folks hang out at Columbia University. Well, there's also a handful of other institutions in the world that play the same game, and they all do it independently. They all gather their own data, and they have slightly different statistical approaches. And it turns out, here are these institutions up here. Here's the different colors are the output of the different institutions. They all match pretty well, which instills more credibility in the whole exercise. Okay, so it's getting warmer with lots of little oscillations up and down in the process. As a corollary, sea level is going up because the more ice we melt with increasing warmth, the more seawater we get. So we see in 1900, we're getting about 0.5 millimeter per year of sea level rise. It's gradually increasing, and presently we're looking at 4.5 millimeters of sea level rise per year. So the rate is going up, which is a little bit scary. Okay, so since 1900 to today, we got about 175 millimeters. We're talking that much sea level rise since 1900 and rising. Okay. All right, that's what mainstream science is trying to explain. The warming and the sea level rise, what is causing it? Okay, the mainstream opinion is that it's human activity causing this current warming since about 1970. Of that human activity, greenhouse gases is the most significant. Deforestation would be the second most significant. Okay. Here's the three major culprits. These are the most potent, highest impact greenhouse gases that are produced by humans. But I want to make it clear, most of this stuff is produced naturally and has always been produced naturally. Humans are just increasing the concentrations of these gases, mainly by burning fossil fuels in our cars and our airplanes. Okay. And how do we know these concentrations are going up? Because they're all being monitored now. In fact, CO2 has been monitored since 1957 on Mauna Kea in Hawaii. And we see an up and down in each year. That's some kind of metabolism of vegetation seasonally effect that I don't know about. If we average through those yearly oscillations, we see this steady rise up until till including 2019. And the same for the other major greenhouse gases. If we go way back, which we can't do instrumentally, but we can do by looking at samples of atmosphere from the old days, and we get such samples from air bubbles in glacier ice, then we see here's the three high impact greenhouse gases the last 2,000 years. They're running pretty steady up until, 1700, 1800. And then as the kid, the boy in the Mazda commercial, when he sees the Mazda go by, he says, zoom, zoom. That was a really stupid commercial. But it kind of explains the history of the greenhouse gas. So what's happening right here? The Industrial Revolution is happening. And we start by burning a lot of coal, and then we get to natural gas and oil. Okay, so greenhouse gases are increasing. We have to overlay that basic premise with a couple of feedback effects. Water vapor is a potent greenhouse gas. Water vapor is not considered to be a human greenhouse gas. I mean, we can create water vapor in a kettle, but it'll eventually rain out again. It's actually the temperature of the air that controls how much water vapor can be in the atmosphere. So we have the makings of a feedback loop here. We can increase the temperature of the atmosphere with whatever we want, say greenhouse gases. That's going to increase evaporation and allow more water vapor to hang out in the atmosphere. Well, because water vapor is a greenhouse gas, it's going to cause even more warming, which is going to cause even more evaporation. And round it goes. So that's a positive feedback effect. Very important in greenhouse theory. This is built into all the models. Second effect is albedo or reflectivity. Snow and ice tend to reflect back most of the oncoming radiation. 15% is actually absorbed by the Earth, but open seawater will absorb 93%. If we can get rid of snow and ice, we're going to increase the absorption of solar radiation. It's going to increase the greenhouse effect, ultimately. So this is also built into the theory. Very important in Canada. Why? Look outside. Here's the albedo feedback loop going round and round and round. Okay. Now, that's the theory. Should we believe it? And there's plenty of websites and books out there saying, no, don't believe it. It's a socialist plot sponsored by the UN to decrease inequality in the world. So let me lay out in a very, hopefully non-technical kind of way, what the basic evidence in support of mainstream theory is. Okay, first of all, greenhouse gases, mean annual temperature rising concurrently. That's pretty simple. Okay, this is not so simple. The upper atmosphere is cooling while the lower atmosphere close to the Earth's surface is warming. So the Earth's surface and the lower atmosphere are warming, but above it, the stratosphere is cooling. Now, I actually have a fairly convincing non-technical explanation of that, but I fear it would take too long. So I'm just going to say this is predicted by greenhouse theory and actually measured, observed by satellites, high-altitude satellites. So the upper atmosphere is indeed cooling. Now, one thing we can grasp here is that this is a nail in the coffin of the solar warming hypothesis. Because if it was the sun responsible for current warming, the entire atmosphere would be warming together. Okay? Now, if greenhouse theory is correct, we're increasing the amount of long-wave radiation that gets rescattered back to Earth. That should be going up. There's instruments on the Earth's surface measuring the downward directed long-wave radiation. Yes, it is increasing. And if it's increasing, the long-wave radiation escaping out into space should be decreasing. There are satellites up there monitoring that, and indeed, the radiation escaping to space is decreasing. So there's excellent observational evidence of an increasing greenhouse effect. This is a different angle, rate and magnitude of current warming. You probably remember the hockey stick arguments. This latest latest attempt to look at past temperature changes using proxy evidence of climate versus what's going on today is this paper that came out in 2019. It's a very rigorous study, and it uses 5 different statistical approaches to come up with these curves. The point being to try and forestall future criticism by skeptics, like happened with the hockey stick curve. So we have several studies using various ways to estimate past climate. Most of these are biological indicators. And we see a lot of slop. We see a lot of slop in the curve, and that's because different statistical approaches are being used, all putting it on one graph, so that all bases are covered. It's very hard to criticize this curve, is what I'm saying. Okay, so we see the little up and down oscillations, natural climate change, cooling off generally into the little ice age, and then zoom, zoom, getting warmer fast, faster than happens naturally. Okay, and number 6, finally, the big guns of the climate scientists are the models, and it's the models that are used to make these predictions that we have to make decisions about now. These general circulation models are numerical models, a bunch of differential equations, computer models with a lot of if-then kind of statements like you played with in your first computer science course, if you ever took one. Okay, and these models attempt to simulate all the interactions between variables happening in the atmosphere, between the atmosphere and the land and the atmosphere and the ocean, such that you can change the inputs. You could change solar input, make the sun warmer or cooler. You could change the composition of the atmosphere, change the amount of greenhouse gases. You could change the amount of glacier ice and snow on the land. You can change all these variables and see how the climate responds. That's the point. Okay, so in order to do this, the modelers break up the Earth's surface into a 2D grid pattern and then break up the atmosphere above into 3D blocks. And they look at the interactions between the blocks. These blocks might be, say, 50 kilometers, 40 kilometers across. And this is all done by trying to solve partial differential equations. So the main thing we have to worry about as society is, can we trust the outputs of the models? This is like the key question society has to deal with right now in mind. Can we trust the output of these models that are telling us by 2100 it's going to be a certain mean annual temperature if we burn a certain amount of fossil fuels? There's 2 ways to test these models, and I don't have time to go into the second way. The first way is hindcasting, the opposite of forecasting. In forecasting, you predict the future by putting in whatever inputs you want. In the hindcast, you predict the past by putting in whatever inputs you want. So here's today, and in this hindcast is an experiment done with 2 sets of climate models. These are the ones that are actually being used today to predict the future in this century. And you put in the inputs like how irradiant you think the sun was back in 1920. You put what the concentrations of greenhouse gases were back in 1900. Put in all these inputs, and the model predicts what the climate should have been in the past. And then you compare that to actual observations. So the colored curves are the model outputs, observations are real life. Divergence here and there, but overall, the general picture, I think, is pretty. Okay, a modeler is not going to attempt to forecast the future if the models don't do a good job with hindcasts. The other way to test the models is take projections that have already been done. Say James Hansen made a projection in 1988, his testimony to the US Congress, and compare those to what happened since then. A lot of study of that has been done, and it comes out pretty positive for the models. So in my opinion, we can't just say, oh, you can't trust a model, so let's not pay any attention to these projections. If you want to say, let's not pay any attention, you're not doing it for logical reasons, you're doing it for political reasons. Now, this, I think, to me, this is the most convincing evidence that there is general validity to the models. This is a hindcast experiment. It's been done by many different people. We first do a hindcast using just what's known about natural forcings, which are mainly volcanism and solar irradiance, and we could also include Earth-Sun orbital relations if we want. And we get this blue curve from, say, 1880 to 2000. Okay, then we do a hindcast using the same natural forcings, but we add anthropogenic forcings, which are mainly greenhouse gases and sulfate aerosols. And we get this red curve. Now we compare those curves with the actual observations of mean annual temperature, which is in black. The red curve passes. The blue curve fails. Now, could you get results like this if there was some unknown major flaw in the modeling exercise? No. What if you're a skeptic and you say, oh, you can't trust models? They're just models. I don't buy any anthropogenic warming. What do you promote then? Usually solar. The Friends of Science in Calgary, they promote, oh, it's the sun. It's the sun. Okay. So we looked at one reason why it's not the sun. Here's the other reason. Here's a graph of solar irradiance, the output of the sun. We see the 11-year sunspot cycle, ups and downs. We average through those, and we see that solar irradiance is generally increasing in the early 20th century. And look how it sort of matches mean annual temperature in the early 20th century. And then starting about 1960, 1970, temperatures start sailing upward. Solar irradiance declines and is still declining. That is the basic argument against the solar hypothesis. As long as we're on skepticism, I could spend a whole talk on skepticism. That's very, very interesting. But let me just go through the opening webpage of the Friends of Science, which is the Calgary group, which is opposed to anthropogenic warming, and look at their 6 points that show up on their main webpage. As late as 2015, they were still saying the Earth is cooling. Even as mean annual temperatures were doing that, they're still claiming the Earth is cooling. This is what I call fake news. There's all sorts of fake news out there these days about everything. And so now we are all faced with this task of trying to figure out who to believe and why. Finally, they're conceding the Earth's atmosphere is warming very slowly. Fair enough. The sun causes climate change. Yes, indeed it does. So what? Presently, the sun is causing cooling of climate. They don't want to tell you about that part. Al Gore was wrong about CO2. What was he wrong about? I think he was basically right about CO2. Violent weather isn't getting worse. Yes, violent weather is getting worse. I could show you some published papers on that. It's been hotter. Yes, indeed, it's been hotter. It's been a lot hotter. It's been a lot colder. So what? Climate computer models are proven wrong. I have no idea what that means. All computer models and all models of any kind are wrong because they're simplifications of reality. I used to make plastic ship models as a kid. Those models are wrong because they're not the real ships. So you got to judge a model by whether or not it's useful. Right and wrong doesn't really make sense. My take on all of this is the Friends of Science don't know anything about science. However, they are friendly. So part of this is okay. Okay, let's end here with, I'm a little behind schedule. Okay, let's end with projections and all this brouhaha going on right now in some quarters of society about trying to keep climate change to 1.5 degrees or 2 degrees. Let's see what that's about. Okay, so what the modelers do is imagine various future scenarios Are we going to burn a lot of fossil fuels? Are we going to try and change our lifestyle right away? And then they imagine certain tracks of greenhouse gas concentrations, and from that they modeled mean annual temperature. So here's 4 scenarios that the IPCC and various individual researchers are now playing with. Here's historical emissions of CO2 and other greenhouse gases going up. Here is the business as usual curve. So let's say I still want to drive around my car. I still want to fly for holidays in Europe or whatever. Let's say we don't want to really change our lifestyle. It's too hard. So we keep burning, kind of increasing at the rate we're doing now. We get business as usual. And the modelers say that by the end of the century, the year 2100, when my 2 grandchildren will each be about 82 years old, so they're going to actually probably live through all this. The modelers say 3.5 to 5.5 degrees over pre-industrial. And you see different estimates in different publications. Often you see about 5. So I think of business as usual leading to about 5 degrees warming over pre-industrial. This is the minimalist curve. And so if we change our lifestyle right away and somehow figure out how to get to renewables really fast, which is a very difficult proposition, nobody really knows how to do that. But let's say we're able to do that, then we're actually going to, so by 2050, we're near zero for emissions. And by the end of the century, this says 1 to 2 degrees, basically. 1.5 to 2 degrees will be our net warming over pre-industrial. So this is what Greta Thunberg would like to see. And then we have 2 intermediate scenarios. Okay, so let's say if business as usual leads to about 5 degrees, there have been 2 serious studies at estimating what the Earth's surface environment would be like with 4 degrees of warming over pre-industrial. And the first is by the Royal Society, and they came out with an issue in 2011, and they suggest that 50% of the world's agricultural land becomes unusable, 40% of the world's species go extinct. This is, in other words, would be a major mass extinction in the history of Earth's life, ranking up there with the kind of mass extinctions that Francois studies, for example. Ocean acidification, increase of 1/4 of a pH, which doesn't sound like much until you remember from high school chemistry that pH is a log 10 scale, and one integer is a 10-fold change. So 1/4 of a pH, big deal. Clams and their shells are already starting to feel the effects of increasing acidity in the Pacific. Coral reef systems are converted to algal mats. That'll probably happen by 2 degrees of warming. It's already happening in the Great Barrier Reef. And the Potsdam Institute in Germany suggests that almost all, around the Mediterranean and in the Middle East, almost all summer months will be warmer than the greatest heat waves now experienced. Sea level rise of 1 meter by 2100, then several more meters after that. 2/3 the population of the Earth, that fraction living in coastal cities, exposed to extreme floods, which will lead to large-scale displacement of those populations, which will further lead to conflict. These guys might be wrong, and they might be right. But for starters, I think the modelers are generally on the right track to project future temperatures. Now, this is just physical, biological stuff. Economists seem to be pretty unanimous these days. That wasn't the case 20 years ago. They seem to be pretty unanimous that the world economy will suffer this huge dent, possibly even like a collapse, with 4 degrees warming. And the most recent paper, well, not the most recent, but a much discussed paper came out in 2018. 23 trillion US will be lost if we rise 4 degrees. This is mainly lost productivity kinds of arguments. This is like every year, not just once, a huge collapse every year. So remember the meltdown in 2008 that we all went through, pretty much wrecked the Alberta oil industry. Imagine 3 or 4 of those financial crises each year. Or imagine something like the Great Depression of 1929 hitting the world, but this time it never ends. Okay, these economists could be wrong, and they might be right. Okay, you and I, we don't have to worry about this. My grandchildren and your grandchildren, if you have some, they may be living through this. That's something to think about. It's even worse here in Canada because we're warming at twice the rate of the mean annual temperature of the world because of our albedo effect, because of our snow and ice. And if we do the business as usual, in 2100, we should end up with 7 to 8 degrees over pre-industrial. Nobody knows what the Earth would be like in that climate. Now, if we're going to meet the 1.5 degree goal that the environmentalists are pushing, we would be already starting to drop our CO2. We would already be changing our lifestyle. We're not. And we'd be close to zero by 2050. Okay, are we going to actually do this? I don't think so. Okay. So they had this meeting in Paris 2015, the Paris conference, and all the countries of the world got together and made pledges of how much they could cut emissions by 2050 in an attempt to end up with, say, 2 degrees or less by the end of the century. They all made pledges depending on their own circumstances. Now, if all these countries met their pledges, we would still end up with 3 degrees of warming by 2100. But nobody is headed towards meeting their pledges. Canada being a great example. Canada's got great aspirations and a charismatic prime minister who says, yeah, we're going to cut emissions. Doesn't look like it. So here's the CO2 curve. Up, up, up. There's the 2019 dot. No sign of declining emissions. So, folks, I think we're headed for heat in this century. And furthermore, Trump has taken the U.S. totally out of the Paris Agreement. He doesn't want to talk. He doesn't want to hear about this. And now people are saying he's going to be reelected for 4 more years. So it doesn't look like we're on track to change our lifestyle. So here's where we are today. We think we got a problem, but we don't want to really change our lifestyles to solve it. So Parliament declared a climate emergency last summer. The Canadian Parliament, at the same time they're approving pipelines. This is the only way you can survive as a government today. You throw a bone to each camp. Because our society is polarized and we can't make a decision that pleases all of society. CBC did a poll last summer. Decided Canadians are worried about climate change. Now, a majority of Canadians think this is actually a real issue that's a big problem. They don't want to pay taxes to do anything about it, which led Andrew Coyne to write a great column in the papers. This also showed up in the Herald. Canadians want something done about climate change and they want someone else to pay for it. If our leaders are hypocrites, we need not look far for an explanation. That's us in this room he's talking about. So that's where we are today. We think it's a problem. A lot of people now believe the science, but can we actually stop driving and flying? Not in the near future. It is too hard for humans to quickly change their lifestyle. So we're in for some very interesting times in this century. You can be optimistic, you can be pessimistic. The optimist says, I'm fucked. Yeah, no, the pessimist says, I'm fucked. The optimist says, yeah, you're fucked. And that's where where we're at. And on that happy note, we will end our discussion. Thank you.